Okay, Algebra 2, this is Troop. I'm going to try doing some screencasting for you guys the next couple of days. Different than what I've done before with the videos. I think the file size will be less. I can go faster and it'll be easier for you guys to follow. So I'm going to be basically running the slideshow like you would see it in class. I'm going to use my mouse. As you can see the cursor moving around. You can stop this whenever you need to take notes, because I'm going to keep burning through it. I won't take breaks just to allow note time taking. So click it, pause it or rewind if you have to listen to some of this stuff over again. So here's our lesson for today called Rational Exponents. Now the word rational we've seen so many times in Algebra 2. Rational meaning rational number. Ratio. Rational numbers, of course, are numbers that can be expressed as fractions. So these are fraction exponents. Fraction exponents. Here's our next slide. Any expression with a radical can be written using rational or fraction exponents, i.e. fraction powers. And we've not seen fraction powers yet, but we're going to be dealing with this for the next couple of days. Any expression that has a radical can be expressed as a fraction power. For example, I'm going to give you a table here with radical expressions on the left, like we've been working with, square roots, third roots, fourth roots, and so on. Then I'm going to show you how to rewrite it in a new way using a fraction power. Here's example number 1, the cube root of 5. Okay, we've seen stuff like this before. There's our index of 3, the third root of 5. We can write this in this area here different way. We write it as 5 to the 1/3 power. Now, when you use a fraction power like this, the 3 on the bottom is the root. Third root index here is 3. Okay, third root index of 3, denominator 3. 5 to the 1/3 power is the cube root of 5. Here's another example. 10, fourth root of 10. Index is 4. So you can write this as 10 to the 1/4 power. Denominator of 4, index of 4. Fourth root means 1/4 power. Here's another example. Square root of 13. Well, no index, so we can assume, again, this is a second root, square root. So that's an index of 2. So this will be 13 to the 1/2 power. Again, the denominator is the root. Root of 2, denominator of 2. Root of 4 on this one up here, denominator of 4, and so on. This is pretty easy stuff. Now, we're going to go the other direction now. Here's a table again, same kind of thing, except I'm going to give you the expression with the rational exponent first, and then we're going to rewrite it as a radical. So this is 11 to the 1/5 power. 5 denominator is the root. So this is the 5th root of 11. Boom. Easy peasy, right? Here's another expression. This is 8 to the 1/3 power. Well, the 3 on the bottom shows the root. This is a third root of 8. Now, if you look at our third root list that I have on the board, written in the classroom there, the cubes, third root of 8 is 2. So we rewrite this as 8 to the 1/3 power as third root of 8, and it can be simplified, equals to 2. When it can be simplified, go ahead and do it. And we'll be dealing with this a lot more tomorrow's lesson. Here's one more. 20 to the 1/4 power. 4 on the bottom, denominator is denoting fourth root. So this is the fourth root of 20. Pretty easy stuff. Whatever the root is on the index, that is your denominator. Fraction powers. Okay, next thing. Show you some more examples where you simplify expressions. We got a lot more of this type of thing tomorrow, but I'm just going to keep it simple for this stuff today. Here is the 16 to the 1/4 power, also known as 16 or fourth root of 16. Okay, fourth root of 16. 4 is the denominator. Here's the fourth root of 16, and if you look at our fourths list that I've got on the board, you know the fourth root of 16 is 2. And we just simplify it. Here's another one. 125 to the 1/3 power. This is which root? Third. This is a cube root of 125, which we've seen many times on the third root list, or the cubes list I've got up on the board. Third root of 125 is 5. Yeah, gotta love it. Now, here's an expression you've not seen yet. Let me show you what happens here. We're doing a multiplication. Multiplication with two numbers that have the same base, 5 and 5. Well, again, when we had that situation, when we're dealing with these exponents we did last couple of weeks, with the same base, you add the powers. So this is 5 to the 1/2 plus 1/2 power. Here it is, 5 to the 1/2 plus 1/2 power. You add those up, you get 5 to the first. This is 5. Now think of it this way, guys. 5 to the 1/2 power is the square root of 5, right? It's the second root. This is also square root of 5. So multiply these two together. Square root of 5 times square root of 5 is 5. That's what we've been doing for the last few weeks. Just different form using irrational powers. Here's another one. 2 to the 1/2 times 2 to the 1/2. They're the same base, so you keep that base of 2 and add the exponents, the powers. So 2 to the 1/2 plus 1/2. This is 2. Square root of 2 times square root of 2 is 2. Yes, gotta love it. Love fraction powers. It just shows basically what we've been doing already with radicals since the last 2 or 3 weeks. Let me show you a few more things here. When the numerator, the top number in the rational exponent, is not equal to 1. See, all the ones we've seen so far have a numerator equal to 1. The numerator, I'm just going to call it for our purposes today, is the power you raise it to. The denominator is the root. Okay, let me explain what I'm talking about here. Here's an example. 25 to the 3/2 power. The numerator, it says up here, I'm going to consider a power, for the lack of a better term, just so you guys understand what's happening here. The numerator is the power we're going to raise the whole expression to. So this whole thing is being raised to the third power. As I move my mouse toward it, the third power. The denominator is the root. So this is a second root, a square root. Let me show you what's basically happening here. 25 to the 3/2, as I'm showing here on this mouse, okay, is equal to one of these two expressions, or both of them, okay? 25 cubed raised to the 1/2 power. What do we do when we have a power to a power? You multiply them. If you multiplied these two, you would get 3/2. Could also be written this way: 25 to the 1/2 power to the third power. 1/2 raised to the third. Multiply those, you get 3/2. Folks, this and this and this are the same thing. Now, I'm going to show you how to write this now as a radical expression. This is a rational exponent expression, a fraction power. Now let's rewrite it as a radical. We know it's a square root because it has an index of 2, and it's being raised to the third power. So let's write it that way. Square root of 25 raised to the third power. Yes, awesome. Now, we can also rewrite this with the power of 3 on the 25 itself, under the radical. Same deal. Both of these are right. Now, all 5 of these situations here listed, that I'm showing with my mouse cursor, are the same expression, written in different forms. As we see in here, the square root of 25 is 5. If you raise that to the third power, you get 125. All of these equal 125. Here's another example. 64 to the 2/3 power. Well, this is the third root of 64, the cube root, and it's being raised to the 2 power. So we rewrite it as a third root of 64 raised to the 2 power. The number on the numerator is the power, if you want to call it that. Okay, what we raise it to, the number on the bottom is the root. And again, you can rewrite this with the 2 power on the 64 itself rather than on the outside. Totally the same thing. I'll take these either way. Doesn't matter to me. Here's one more. 16 to the 3 halves. Square root of 16 raised to the 3rd power. There's the square root of 16 raised to the 3rd power. Or you can write the 3rd power on the 16 itself. It's the same thing, guys. And again, on this one here, the square root of 16 we know is 4. Well, 4 to the 3rd power, 64. And you can do the same thing with this up here. All right. One more thing I'm going to mention, a couple more examples here before we finish this up. This is an expression where you're multiplying two things together that have the same power, but the base is different. Okay, now we got a problem. Well, maybe we do, maybe we don't. Here's the thing. You change this expression so that the bases are the same, so that we can add the powers. It turns out, folks, that 8 is 2 raised to the 3rd power. If you look at our cubes list, you see 8 up there. Cube root of 8 is 2. 2 to the 3rd power is 8. So I'm going to rewrite the 8 as 2 to the 3rd power. Now follow along here, guys. I'm just going to show you the whole thing. So let me explain what's going on here. Follow my mouse. All right, so here is the expression we're starting with, right? The 8 I'm going to rewrite as this. 8 is 2 to the 3rd power, raised to the half, just like it shows right here. Now follow along in the next step. Okay, we have our new expression here, rewritten with the 8 as 2 to the 3rd power. Go here now. Power to a power. 3 times a half is, well, 3 times a half. Okay, now let's move on to the next deal down here. 3 times a half is 3 halves. You see how I'm simplifying this. Now look at what we got. The base of 2. Gotta love it. Now we can add those powers, as you see right here. Add the 2 together. You get 2 to the 4 halves, or 2 squared. Boom! And all that stuff is equal to 4. Love it. Good stuff. The stuff you can do with fraction powers. Okay, if you need to pause that and write it all out, go for it. But I'm going to move on to the last example. Here's an example with 10 and 100 as the bases. Well, the bases are not the same, so we can't add the powers yet. However, we can rewrite that 100 as a base of 10. 10 to the what power is 100, folks? 10 squared. So we rewrite this 100 as 10 to the 2nd power raised to the 1/3. So here's the next expression with the whole thing worked out. Follow along here. So this first expression is now here. What has changed? Well, the 10 squared is where the 100 was. Okay. And then we multiply the power to a power here. 2 times the 1/3, which gives us this. 2 times the 3rd is 2/3. So I'm just doing it step by step as you go through this. Now the powers, or the bases are the same, guys. Now we can add the powers together. We get 1/3 plus 2/3, which is just 3/3. That's 10 to the 1st power. 10. Awesome stuff. Hope you enjoyed the show. You should have a worksheet called Rational Exponents number 1. And let's check it out and see how it works. Later.